So we're going to go north to learn about annual layers in ice cores from Greenland. I've labeled this a good day in Greenland. We had been there for a month, so those newspapers were actually not very current. But they were useful for some things, and so this is a good day. This, you can see, is a bad day in Greenland. We were working up there all summer for many years. This is our 4th of July party. Um, After a month or so up there, you'd want to rinse out your underwear. You can see the icicles on my freeze dried laundry. We sometimes had really big storms, and after a storm, the snow surface might look like this. It would have a lot of snow drifts, but it's sort of smooth at the small scale. And then we'd have these beautiful sunny days that almost but not quite got up to freezing. And then at night, this is the midnight sun, you would get fogs and they would grow frost on everything. Very spectacular frost. On the volleyball net there next to my lens cap, where we would go out skiing for exercise, there's frost on everything. If I take my pocket knife and I slice out a little piece of snow and bring it up where you can see it, the wind-packed snow from the storm is down an inch or two, a couple of centimeters. The very top has actually sublimated. It was heated by the sun. The vapor went up in the air, and then it came down to make the frost. So you get this low-density, coarse-grained layer on top of the snow. Now, what are we going to do? There's Joan Fitzpatrick of the United States Geological Survey wearing the flannel shirt. That's me without a shirt. We're digging 2 holes. We're going to put a lid over one of them, the one that Joan and I are in, and let the sun shine through the wall from the other one. So here's me going down into a pit, and this is the wall. This happens to be only about 6 inches of it. Snow is blue, more or less the same reasons that water is blue. The red is absorbed a little bit. And we're looking at some of those low-density layers that form during the summer when the sun is intense. If we back up and look at the whole wall, this was about 6 feet deep, which is as deep as we could dig easily. On top is the snow that accumulated during the previous winter, and then the previous summer, and another winter, and another summer, and another winter, and another summer, and then it's a little too deep for us to dig deeper. We did a huge amount of work to demonstrate that these really are winter, summer, winter, summer, winter, summer. Now, we're going to drill an ice core with the big drill. Here's Catherine from Alaska on the big drill. Take the core, put it down into our under snow laboratory. Here's Bill from New Hampshire down there. Wanda Kapsner, who was a Penn State student at the time and went on to be a teacher and to run a winery, and she's studying a thin section of an ice core. Here are a bunch of cores. The 1547 there means 1,547 meters down. That's almost a mile, where the ice was about 10,000 years old. And here's Kurt Cuffey, who was an undergrad then and became a famous professor, and he's studying an ice core. And this is what he's looking at. This one is from 1,411 meters down, or about 8,400 years old. And there's a winter. The summers look dark now. Those low-density layers gave big crystals and big bubbles, which in this transmitted light on our light table look dark. So the summer looks dark, and there's a winter, and there's a summer, and there's a winter. Again, huge amount of effort to test that this really is accurate, and it is. And we were able to count more than 100,000 annual layers in this core. So that's a little bit of how we get an annually resolved record from an ice core.